Okay, math nuts. Question 36. It says, which of the following tables of values represents a linear relationship? And this is number A here, or I guess it's the letter A. I don't know my A. And those are all of my values for table A. Well, how do I tell if it's linear? Well, a linear relationship, if I was to graph, I'm just going to do it here. Actually, I should have made more than one quadrant because there actually is more than one here. X negative 1, Y negative 1's there. 1, 3 is up here. 3, 7 is up here somewhere. If I was to actually graph those through there, I actually see that it forms a line like that. But that's not the only way to prove if it's a linear relationship. What I have to be able to do is create an equation. That can represent this linear relationship, and that's the one way I can figure out if it's linear. I can obviously plot them, but there's other ways to do it. So I look here and I notice that if I follow up and down here, it's actually jumping by 2 every time. From negative 1 to 1 is a difference of 2. 1 to 3 is a difference of 2. Difference of 2. Difference of 2. That's good. And here we have a difference of 4 each time. Now that in itself, looking at a table of values, if that's the case, then we can say definitively this is linear. And that kind of ruins all the suspense because B, C, and D, obviously, since this is multiple choice, don't work. Let's check here. This goes up by 2, by 2, by 2, by... Oh, it works here. Look, up by 2. That's half our battle. From negative 1 to 5 is 6. From 5 to 11 is 6. From 11 to 17 is 6. And didn't work. Went 6, 6, 6, and then negative 3. Oh, well. Not linear. Have a look at C. Difference of 2, 2, 2, and 2. It works there. Difference of nothing. Difference of 8. Difference of, oh gosh, I don't know, like 16. Difference of whatever. But it is interesting. Haha, even though it's not linear, it is interesting to look at it. If we look here, if we were to find the equation, if I was to square the x value, I get the y, which we'll look at later on in probably grade 10 or so. You're going to find out what that's called and what it looks like. Kind of has a little loopy thing to it. It's really kind of funky. But you'll see it in grade 10 or 11 or maybe 12. I don't know. Or maybe you'll never do it. And then the last one goes up by 2, by 2, by 2, by 2, goes up by 1, goes up by 3, goes up by 5, goes up by 7. That 1, 3, 5, 7, this is not consistent, therefore it's not linear. It doesn't work. So it's not linear. But let's go back to that first one, and let's see if we can figure out what is the equation that works for it. Well, the interesting thing is, if I was to fill in the data here, and I really need this to be kind of full here. So I'm going to go like that, and I'm going to fill in the missing values here. So it would only go up by 2, so we'd have 1 here, we'd have 5 here, and we'd have 9 here, we have 11 there, we'd have 13 here. And the difference between each of these values is only 2, 2, 2. So from 1 to, or from negative 1 to 1, from to 3 to 5 to 7 to 9, etc. The difference for those is 2. That's really messy. So all I did is what I filled in, so it's difference of 1 here, and then the difference between there, that actually works out really well. So if I was to put x and y here, because this is now going up by 1, so negative 1 to 0 to 1 to 2 to 3 to 4 to 5, and I filled in the values, and the difference of each value is only 2 between those, that actually becomes the coefficient of my equation. Now this is going to be a little confusing because it's really messy in here, but let's just take a look at 6, for example. My x value is 6, because it says so right here, my x value is 6, and my y value is 13. Well, I know the coefficient's 2, so I double 6, and I get 12. What kind of constant do I need to add to get to 13? Well, I have to add 1. That worked for that one. Let's check this one out. So 2x, or 2 7s, is 14, plus 1 gets me 15. 2 4s is 8, plus 1 is 9. It works. So this is the equation, the linear equation. And that's how we can figure out that things are linear. If we can create an equation that matches for all the set values in the table of values, then it makes it linear. Interesting, isn't it? Lovely.